Picture this, autonomous robots all over a construction site, just tirelessly scanning, measuring, and building. It's not some far-off dream, it's really the direction we're headed. But there's this one giant problem. The second a robot goes inside, it's basically flying blind. GPS just doesn't work through concrete and steel, so our super advanced robot is suddenly lost. How in the world do you solve that?
So yeah, that's the big question we're tackling today. We're going to break down the surprisingly clever way engineers are giving these robots a whole new way to see indoors. And it all kicks off with a massive shift that's happening across the entire construction industry.
You've probably heard of Industry 4.0, right? The fourth industrial revolution? Well, construction is having its own moment. It's called Construction 4.0, and it's a complete rethinking of how we design, build, and even operate everything from huge skyscrapers to your own home.
So, what is it exactly? Well, you can think of Construction 4.0 as this framework where a ton of different technologies and trends are all hitting at the same time. This isn't just about one single invention. It's what happens when powerful tools like AI, robotics, and big data all start to merge and, well, completely reshape how we build things. It pretty much boils down to three main themes. First, you've got industrial production. Think prefabrication, 3D printing, building parts in a factory. Then there are the digital technologies. That's the brains, AI and big data. And smack in the middle, you have cyber-physical systems. And that's where we're focused today, because that's where the robots, drones, and smart sensors come in.
Okay, so we have this amazing vision of smart, automated construction. But when we try to bring these robots off the computer screen and into the real world, we hit a wall, a very, very literal signal-blocking wall.
It's really that simple, and that massive of a problem. The system that we rely on for everything, our cars, our phones, drones, it's completely useless the second you step inside. So our poor construction robot is basically stuck at the front door.
And think about it. A construction site is chaos, right? It's not some static office building. Walls are going up, stuff gets moved around. The layout can change from one day to the next. How is a robot supposed to navigate all that without a reliable signal? Well, the answer is kind of brilliant. You just stop relying on an outside signal and you create your own.
And this is how you do it. Meet the fiducial marker. It is the absolute key to everything. You can think of them like digital breadcrumbs or maybe an indoor constellation of stars that the robot uses to navigate. They're just simple, cheap visual patterns that a robot's camera can spot instantly and use to figure out exactly where it is and which way it's facing.
Okay, but you can't just go around slapping these things on the walls and hope for the best. There's a really deliberate process for designing what's called a marker network. It's a whole strategy for building a custom indoor road system just for the robot.
So the process really breaks down into a few key steps. First, you got to define the mission. What exactly is this robot supposed to be doing? Then you figure out which robot you're using, because its camera and sensors affect how it sees the world. Based on that, you pick the right size and type of markers. And finally, you get strategic. You actually plan out the entire network, calculating the distances to make sure the robot can always see at least one marker so it never ever gets lost.
And what's cool is that creating this map pulls in all those different parts of Construction 4.0 we talked about. You need the physical robotics and automation, but you also need the digital side with AI and data analytics. When it all works together, you get this, a marker network map. Seriously, just think of it as the robot's personal Google Maps for indoors. Each marker is a known address, letting it plot the perfect path from A to B.
So, problem solved, right? We've got a map. Well, not quite. There's another, much sneakier problem that every mobile robot has to deal with, whether it's on a construction site or, on Mars. It's a tiny little error that can lead to total failure.
It's called drift accumulation. See, no robot's movement is absolutely perfect. A wheel might slip just a fraction of an inch, or a turn might be off by 1/100 of a degree. On its own, no big deal. But over a long trip, those tiny little errors start to add up. They accumulate, causing the robot to drift farther and farther off course until, bang, it runs into a wall it wasn't expecting.
So how do our little fiducial markers fix this? Well, they give the robot the perfect chance to constantly check its own work and fix its mistakes on the fly.
This is the crucial part. The robot isn't just blindly following the map, it's constantly course correcting. So it drives for a little bit, it sees a marker, and it basically says to itself, okay, the map tells me that marker should be right there, but my camera sees it just a little bit to the left. That means I've drifted. And then it makes a tiny adjustment to its position, and bam, the error is reset to 0 before it has a chance to build up. And look, this isn't just a theory. It's a whole system where the digital tools and the data on top are connected to the physical construction happening on the bottom. Our robot is the link. It's the thing that's actually down there in the physical world, camera and sensors running, patrolling the site all on its own, using those markers as its guide.
So, okay, we did it. We have a robot that can get around indoors without getting lost. That's a huge win for the engineers. But what's the actual practical benefit on a real project? I mean, why go through all this trouble in the first place?
The answer is one word: data. But not just any data. We're talking about consistent, reliable, high-frequency data. This robot's whole job is to be a tireless little monitor, collecting information that would be boring, expensive, and frankly, pretty inconsistent for a human to try and get.
In this specific case study, the robot was loaded up with sensors to gather key environmental data. Just imagine for a second, maybe you're trying to cure concrete or install some really sensitive wood flooring. Having a precise, minute-by-minute record of the temperature and humidity across the entire site, that's an absolute game changer for quality control.
And when you actually compare the robot's work to the old way of doing things, the difference is just night and day. A person might take some readings, once a day? The robot can do it every hour. A person's measurements might be a little different each time. The robots are perfectly consistent. And yeah, over the life of a big project, the cost of running the robot is way, way less than the labor cost.
So let's just zoom out for the big picture here. This isn't just about collecting a bunch of numbers. It's about what that data lets you do. It leads to way better quality control. You can monitor things like air quality for worker safety in real time. Your teams aren't guessing about site conditions anymore. They're talking to each other using hard data. And all adds up to another layer of super efficient, automated progress tracking for the whole project.
This kind of technology really unlocks automation for all these indoor tasks we used to think were just too complicated for a robot. It really makes you wonder, doesn't it? Now that they can finally find their way around, what's the first tedious, repetitive, data-driven task in your world that you'd hand over to a robot?